Greetings everyone, thank you everyone online who's been patiently waiting. We were chatting, well I was chatting and I lost track of the time, my apologies. So we are getting ready to start. My name is Adam Hems. My day job is to spend all day talking to customers about Azure, ex-Microsoft, doing consulting now. So really cloud is my idea of fun. I'm doing it for 15 years actually. And so I also with my colleague and fellow leader, Kim Vadi. And so together, we've been running this group now since 2016, together for years and years. And our focus is to help build a community here in Houston with all the people that use Azure, which nowadays, kind of a lot, honestly. There's a lot, it's popular. Yeah, people seem to like it. So we, in our day jobs, tend to, we talk to Microsoft customers and, in my case, clients all day, every day. But what we don't get the opportunity is to let folks learn from one another and do other community-like things like network, look for jobs, find people for jobs, things like that. So that is a key part of what we're trying to do here. What we're not trying to do, because often as part of our sales service, sales pitches, because no one wants that. No one's come for that. So no sales pitches. That's not what we're about. We're about learning. Here to learn from the speaker and from one another. And so that's what we're looking to do. So welcome. Who's new? I see a lot of familiar faces. No, you've been here before. Everyone else has been here before? You guys. Okay. Welcome newbies. Welcome. So we're online as well, and we're recording it. It's going on YouTube. He is also doing a fantastic job of videoing. Thank you, he. Really appreciate it. So anyone who misses it or needs to go, then we'll post it on our YouTube channel. For those of you in the room, the microphones are at the back as well. So try to avoid having problems do that. Just FYI. And the pizza is the courtesy of the Canonical folks who are speaking tonight. So thank you guys for sponsoring us. We really appreciate it. Yeah, thank you. We need to eat, and we like having it in person, right? Because we can't have these in person unless somebody sponsors it. And we've tried doing it online. We did that during the pandy, right? And it wasn't that much fun, frankly. So we like coming here in person. So we appreciate that. So with that, and without further ado, let me hand it on to Brandon.
Yes, absolutely. Thank you, Adam. I guess long and short of it is my role here, and while you get up the slides, I am the resident sales guy, so I'm going to try to talk as little as possible because this isn't for sales pitches. But I am going to sort of step in to introduce the team here, introduce Canonical, just provide sort of background context. We'll kind of go from there. Is it working? Perfect. That's a quickie. Okay, so here are all of our beautiful faces up on a slide. Everyone can wave. You'll also notice that my picture is slightly bigger than the rest because I'm in sales and I have the biggest ego. So I also have the biggest picture.
Legit.
It works that way.
Legit.
See, exactly. Make it a little bit bigger. You can see my face a little better. But we have, obviously, Cammy, Yash, because I'm myself. So these are all of the fun folks from Canonical joining us here today. And now I'm just going to give you sort of the quick introduction to Canonical for those of you who don't know us. Broadly speaking, you will know us from Ubuntu, and I'll talk about that in a second. But fundamentally, our mission statement is to enable, effectively to enable the world, the enterprise world, to adopt open source with enterprise-grade support, all of the sort of assurances you need, and basically our goal is to be the most widely distributed software company on the planet. Now, because this is open source, that also means we will probably not be the largest software company on the planet by revenue, and we're all okay with that. Even me, the sales guy. So this is where everybody knows us well, which is Ubuntu in VMs, on Azure, anywhere else, right? Across this, we have sort of standard Ubuntu server, LTS, all of the releases that we have on our shirts are all different Ubuntu releases, which are all different little animals with fun little names. But we also have a sort of core product offering for the market, which is Ubuntu Pro, which is to provide the additional security and compliance requirements and all sorts of fun assurances that you might need. But I don't want to just spend a bunch of time talking about Ubuntu, because I figure everybody in this room already knows it. What I do want to do is kind of provide the background before we get into the fun stuff. And that background is basically that we have a fairly large product portfolio at this point, built upon that initial sort of foundation of we know how to roll and distribute an operating system, which is one of the most fundamentally difficult pieces of software to maintain, distribute, security patch, support, etc. We've taken that kind of core logic and we have applied it from effectively certified bare metal hardware up through orchestration, obviously providing an OS, our standard systems management tools, all sorts of infrastructure management tools, right? Whether that be our microcloud or OpenStack, our distribution of Kubernetes, up through the sort of tool space, into the application space, into the container space, and you'll also see mentioned on here at the top, container build service, which is also a very interesting thing that if anybody wants to talk about, come grab me at the end of this. Basically, we are building and packaging containers based upon customer requirements, including the dependencies, long-term supporting them, long-term securing them for an extended cycle. And we have a whole bunch of those projects going, so it's kind of an interesting thing to talk about. And finally, while I go through my final bits of this speech here, we kind of have a slicing of the offerings across these, right? Fundamentally what we do, enterprise support, engineering services, basically enabling you to get to production and then supporting you once you're in production. That is the core goal here. The final sort of piece that I want to talk about before we get into the fun stuff is just to sort of talk about high level where we see sort of with customer projects, what kind of machine learning use cases are we seeing. Some of those are predictive maintenance for physical oil pipelines, modeling of oil pockets, all of that sort of geological fun stuff. Summarizing drilling reports, not very fun, but pretty useful. And finally, sort of ROI calculations and things of that nature. It's kind of, Houston specific to industry, rather than doing the genericized. And I'm gonna sort of pass it off and let you take it from here.
Sure. Thanks, Brendan. Hey all. I first want to drive the need for why you are on here. I guess you bought the word Kubeflow. You wanted to know what it is about and how you could get your hands dirty with it if you want to try things. But before we jump into the how and why, we need to first establish why you would need an MLOps platform and what does even MLOps stand for and how this relates to Kubeflow. Right, this is, we are looking at a situation where there is a proliferation of tools everywhere. You have new LLM tools coming about, you have new ways to consume models that are getting generated. However, when you think of things in an enterprise setting where you need very clear versioned, maintainable pipelines that you would want to, in this case I'm talking about workflow pipelines, that you want repeatability and you want better access and configuration, maybe if you want to manage multiple tenants and whatnot. If you think of that, MLOps solutions like Kubeflow come in the first picture, where you want a unified setup, where you can all engineers can use the platform. The other thing is this setup is it's very scalable and it can work on different environments. So you could use data that exists already in your existing setups. So for instance, you guys must be familiar with Azure and everything that comes with Azure. Maybe you have blob storage, different load balancer services. You could also have auto scaling that you were using in order to maintain your production workload. You could consume all these in order to make your ML machine learning operations more scalable and maintainable, right? This translates directly to an easier platform to manage and scale, both for administrators who need to ensure your setup is fine, and also for those who want to expand. If you want to procure new setups that need to use the AI story for training and consuming, basically making it available to your users. Finally, this is all centered on machine learning models and data science. So this gives you an easier way. The MLOps frameworks gives you a very straightforward way to manage your models and also to create workflow pipelines. And finally, you can also have a holistic view of what's happening behind the scenes to know how many notebooks, in this case, how many users are using these services, how much does that translate to cost, right? And what are the active jobs that are running in order for you to train your machine learning models. So this is all a quick overview of why you would need an MLOps platform, and that directly maps to the next crucial point. We are talking about public clouds, right? We need to ensure that your public clouds are secure, right? And every data that you bring in has the chance to get data leaks. You guys must have heard of recent issues where the very famous Claude code actually uploaded its source code online. You understand how critical it is when you are dealing with highly sensitive and credential specific data. So the idea of going towards a managed solution, which is what we will be seeing next, is to actually minimize disruptions if there are issues, vulnerabilities found, exposures that you need to fix. A managed and secure solution takes care of that. This also provides you with the assurance that your data remains safe, there are no data leaks. You also have the ability to dedicate resources that use particular hardware. For instance, you want to do some training that requires very specific and expensive GPUs. So you can use this setup in order to focus resources. And finally, you have, like I said, the same platform that gives you the ability to leverage the same setup for every use case that you'd want to do on your Azure setup. And like I mentioned earlier, it's the CV patching, security maintenance that comes under the hood, meaning as users and administrators of a machine learning setup, you are not going to worry about that. It gets taken care of under the behind the scenes rather. So before we jump into the demo, I want to show where Canonical's expertise comes. Pretty much every logo that you see on the screen, for one, is an open source project, meaning anybody can fork it, improve it, and make the tool better. The other thing is Canonical. Where does Canonical picture here? Canonical ensures that there are easy, straightforward ways to consume these projects in a way that makes the end user just do like a click to get your features together and then start using the solutions. So you can actually see Kubeflow and MLflow on the center of the screen, which is what we'll be focusing on. But keep in mind that pretty much everything you see here has the opportunity to be integrated in a solution that is provided to you, right? So I want to classify that into different bins. In this case, we'll do a quick poll in a bit to understand where you guys are proficient in and what your background is, to understand that better. But in general, you have 4 large segments when you talk about AI and ML workflows, right? You need data to do ML, right? AI, ML. Those could be different types. As you see, you have MySQL, you have other kinds of semi-structured or even unstructured data. There are open source projects that directly relate to that can also be used, right? And the data that you get needs to be processed before you can make any sense of that. That's where you get Slurm-like solutions which can do batch data processing. In this case, we have Apache Spark. Our main hero of today would be the MLOps segment, where you have the ability to understand interesting features. Right? We'll be seeing a demo on all of what I'm talking about right now. And then we also have the ability to train your models and then make it available. So eventually, whatever you do will need to be consumed by your users and get feedback so you can complete the loop, right? To make it an enterprise ready offering. Finally, you also have the visualization, which helps complete the picture by showing you how your model works with real-time data. So you may use some data to train things, and when it actually goes to your end user, they are going to feed it new data, and for you to visualize that and fine-tune your models, you would go ahead with the setup. So we'll do a quick poll here to understand where you guys, or what background you guys have. So I can tailor my, ensure I cover those parts during the demo fine. So this is a quick question. You have a QR code that might be, I guess, small. Let me try to Is there? Yeah. I will try to use a magnifier.
If that doesn't work, you want to raise a hand again?
Yeah.
Yeah, I think.
Yeah, we can try to.
Yeah.
I think we could do that. Maybe also for the virtual folks, so I can see when you raise your hand. So anybody here who is on the infrastructure management side, meaning spin up VMs, take care of public clouds, okay?
Raise your hand multiple times if it's not exactly
Yeah,
that.
okay.
That's fine.
Any database administrators, people who? Oh, okay. I see. All right. Thanks. People whose main focus is AI and machine learning engineering, meaning to ensure training of models, to basically work in the whole pipeline, starting from validation, testing, and all that. Okay. All right. I see there's quite a few folks here. Anyone on DevOps, and CI/CD pipelines, ensuring that's all. Okay. We've got right. Okay. Awesome. Data analysts or data science engineers. Okay, we've got good representation on all these segments. That's good to know. I guess this is just to keep everyone included, people management. So yeah. All right. Anybody else in the other segment that is here to just hang around? Okay, so we mean business here. All right, let's. I think we have a good number of hands that went for AI/ML engineering, DevOps and MLOps, right? So our demo will be focused especially on that. So thanks for let's assume this is all completed. I'll work on ensuring the QR code is large enough. Cool. So this is, I just have a couple more slides before I jump to the interactive demo, so please bear with me. This is just a quick, explainer of what the solution is and how we are doing it. So you can actually use the Kubeflow setup and run your experiments and do what you want with the AI story, right? The main component here is charmed Kubeflow. A charm is basically, I'll expand on that later, it's how Canonical binds all our applications and solutions together in an easy to manage way. So you don't have to think of any open source project, right? With LLMs, it's getting quite clearer, like you get clear step-by-step instructions on how to deploy a solution. But earlier, you had to go through some README files, you had to experiment with things, encounter issues and all that. Charms actually simplify the whole story by pre-packaging the lifecycle of an application. You need a database, we have the exact configurations, the defaults, the necessary integrations that you would need for other components to work. So in this case, we have Kubeflow, which integrates with MLflow. We'll look at that in a bit. And it also gives you native observability, meaning you can monitor what's happening on your setup as an administrator of sorts, right? You also have the ability to expand this to all the other products that we saw in the portfolio slide. This is basically how we do the entire end-to-end machine learning flow story. A quick overview on the Kubeflow ecosystem. I'll be showing you through all these. You have dashboard. I guess it's quite self-explanatory. The human-facing part. You have the plain old Jupyter Notebooks, or maybe there might be VS Code experts here. People with data science backgrounds might prefer doing RStudio assessments. So you have those. And I guess these are familiar names, machine learning frameworks and libraries. TensorFlow, it's quite old, but you still have it. We have PyTorch, we have XGBoost and all these that are already available that can be consumed when you do your machine learning, right? You also have pipelines. I want to clarify, this is a workflow pipeline. Basically how you explain each process of the machine learning part. And we have an oil and gas oriented pipeline demo as well, so let's keep that separate. You can also run experiments. Basically, once you have defined what you need done, you can run these as instances basically to see how well your pipeline fares. You can do some fine tuning with hyperparameters. There are things like automated machine learning that you could do. And finally, once you have your model ready, just like you have Claude Opus or Gemini 3, you would need to serve that to your users in order to see how it fares. Right? And this is more like a continuous process, which is why the MLOps becomes very relevant. You'll need to fine tune models later on. So we have tools for that as well. We'll be jumping to the UI in a bit, but in common, you'll have like 3 different stages where you want to do interactive exploration, right, of whatever data you got, and then you want to make sense of the data by getting a machine learning model, right, which usually gets into the data science workflow, right. So you could use structure and basically a CI/CD kind of a setup that you could run. And finally, once you have this model trained, you can then serve your models at scale. This is where Kubeflow becomes very crucial, and it stands out because we are actually using Kubernetes under the hood, right? And you know how Kubernetes, I guess we have AKS, which is what our solution is using, Azure Kubernetes Service. In fact, our solution or demo, the entire setup is running on Azure Kubernetes Service. So what do you get with it? The components you know or you've used so far, like load balancing, dynamic node pools, you can scale your nodes and all that. So you have that as well, right? With that done, some advantages of the managed Kubeflow setup on Azure particularly. The deployment is easy and straightforward because we are targeting Azure, which is a public cloud. Yeah, that's a question. Do we?
Ask a stupid question?
No questions are stupid. Do we have a... Yeah.
Yeah. So just no, that's fine. That's fine. I think there's not many people. I just wanted to understand. I always like to see the big picture. So, so you're talking about the Kubeflow. How was it done before Kubeflow entered into the picture? So, what were the traditional methods which Kubeflow now facilitates better?
All right. So the question is, before Kubeflow, how people used to do machine learning, right? For one, we were running plain simple Python files that did not have access to the hardware that would actually do the machine learning. So for instance, you would code your solution in a file which did and on a laptop that may not have the necessary compute. So this had to then be copied manually into some data server, like maybe some kind of a physical hardware compute on a server, or you should use the Google Colab or some kind of Microsoft Azure GPU settings, right? So you will have to move the content over there, which actually caused a lot of drift. So when you do some changes on your setup, you don't know if it will actually work just fine when it gets to the public cloud. So these are the frictions that actually led to the development of the entire Kubeflow project. I'm just giving you an example of dependency on hardware. Now think about what happens when the model gets trained, right? You'll have version 1. Now we don't know if that version 1 is actually the best, or how do you evaluate the model, right? This had to be sent over in some kind of a pickle file or some kind of a Parquet file that gets used later on by your consumers, and the feedback would need to be manually integrated. They say they don't, the feedback might be that the model doesn't fit well, maybe it's overfitted. This was not easy for you to incorporate or identify what went wrong because there was no one unified single setup for you to test. With Kubeflow and MLflow, this gets integrated, as I'll just show in a bit, within a single platform where you know what data was fed into what model and what was the version that got out. You have the ability, taking an LLM example, give a prompt, evaluate the prompt with 2 versions of the model. You have the ability to do all that thanks to Kubeflow and MLflow. So that's the long and short of it. I think you said you had another question?
Yeah, it's a configuration system, a configuration management system, as well as repeatable.
Right.
Okay.
Exactly. Yeah.
Thank you.
Any questions virtually? Okay, cool. Please raise your hand, virtual attendees, if you have a question, I will take it. And feel free to interrupt me anytime. Yeah. So this is where things get interesting. I think I did cover all these. Just to highlight, give a quick highlight, you deploy TCD, meaning your solutions are accelerated, you get a quick TTM because you have a centralized setup. It integrates with your Azure platform settings and you have full compatibility. And this is managed by a single provider on 2 fronts. On the infrastructure, it's Azure. right? So you know what VMs and how the GPU pools will work like, for instance. And you have Canonical, which is providing services under the hood for this solution, right? Kubeflow. So those two things will actually eliminate the headache you will have, operating things, and the native observability. Grafana, Prometheus, anyone? You guys must have heard of that. Right. Okay. In case you don't know, I'll show you a quick overview of what you could get out of the solution. Right. Okay. So with that, let's do. This page must be familiar to you. I'm just showing you how I would deploy a solution. Right. Head over to a marketplace. Search. This is currently in the private beta phase. So definitely check with Brandon or Yash for access to this. You'd go ahead. I just want to point out some specific aspects. You need to have the subscription to do it, meaning you should have already an Azure account or a corporate account, right? The other thing I'd want to point out is you have a user email. This is relevant in the sense that this email is what you would use in order to contact Canonical support if you have issues, if you have some queries about how to change the features of your Kubeflow deployment once it's done, right? Another thing to know is you have the concept of high availability. So that brings multiple nodes just in case your management plane, what Canonical uses to maintain your solution, right? So you could choose that. Actually, HA is necessary for production, but if you are just doing some tests, you can ignore that. You can choose your VM size, what kind of CPU, RAM you need to run on your control plane nodes and the worker pools. A specific note here is we could do a CPU specific pool. We could also do a GPU specific pool, and you can note that there is a mild difference in the VM size that you use. In this case, we are using a Tesla T4 GPU on the deployment. And the reason I pointed that out is if you later on want to change the configuration, you need to contact Canonical support. It's still something that we haven't exposed that you can change later on, but yeah, that's the relevance here. Finally, you provide some details to do some access configuration and you do some review of the final deployment. So it's basically like a template that you deploy. Once you do it, this page should be quite similar. It's a managed application and the deployment gets completed. At this point, you would receive an email on the user email that you just provided that would look more or less like this. Which explains where you need to access the Kubeflow UI, right, in order to do your experimentation, right. This is the long and short of it. I think it's demo time. I will.
Question, Vikas?
Yep.
So it looked like you had a regular AKS cluster with GPU nodes, right?
That's correct. Yep.
Okay. How many GPU nodes do you typically spin up?
It's variable. For one, these are node pools, meaning you can assign one particular set for all GPUs, right? And we currently have the ability to do zero nodes in a pool to 16 nodes in a pool.
16.
So that's where the auto scaling comes in. As long as you don't need a GPU, you know how expensive those are. So yeah. Go ahead.
I read somewhere, I think on the Meetup description, that this is related to oil and gas environment demo, right? What particular use case are you considering here? Is it upstream, downstream, and then what particular use case are you working on?
Yeah, the demo we have is more of an exploratory data analysis of an openly available data set for oil and gas pipelines. We use a simple setup. I'll be walking you through the demo. In fact, I'll do that first. Maybe if that's relevant.
Because I got more questions. So
Yep.
which GPUs do you support? Which ones do you have? Do you require?
Any GPU that's available on Azure,
Okay.
you could deploy that. And this is all going to be deployed as a part of your AKS cluster. So anything that AKS supports, you can bring it into this deployment. Yeah, it's a good one. Right. So let me move over to the.
Oh, there's one question.
Oh, that's a question. Sure. One second.
Thank you. I'm wondering, are we going to be seeing an architecture of Kubeflow as well?
Right. The answer to that is no, because that's what's happening behind the scenes. We are focusing on what you could do with such a deployment and utilize it. I'll be happy to share more details if you want, but I guess we have a lot of data engineers and AML experts who don't care how you deploy it, but care how I can benefit out of it. So what we see here, just a moment, this is our Kubeflow UI. So I think this looks pretty similar to what I showed you on the slides, right? The question I got was how, or the architecture behind this deployment. We can probably take it offline if you're interested, but I'm going to focus on what happens after the deployment is done, right? So the first demonstration we have is actually on the, I'll actually go ahead with the oil and gas pipeline since that is of interest.
Yep. To zoom it, it's very hard to see.
Sure.
Everyone just come
Maybe
to the
just make a full
first two
screen.
rows and then,
Maybe get closer.
yeah, get closer. The last row.
I think, yeah, we have a lot of,
If you can get a full screen thing, I think that might help you.
sure, we can try that. Does it help?
Well,
Maybe.
instead of Zoom or the, sorry, the.
Plenty of space up here in front.
Yeah,
Just saying. Lots of room.
Okay. I think it definitely is more readable from closer.
I can see it really well.
All right. So what we have here is actually a pipeline demonstration, meaning this is you have a data set that's openly available. We have the Kaggle data set for this, which is available right over here. Kaggle is basically a repository where you can make open source contributions of data sets and machine learning code that you'd want to test, right? So I am using the data that you get from here. In fact, this CSV file, it's right here. It's about 70 KB. That's what we are using in this pipeline demonstration, right? So again, this is not my code. There are people who are real experts like you folks who focus on the oil and gas ins and outs. What we do here is actually predictive maintenance assessment to understand how or which part of your oil and gas pipeline would need attention to see if it's going to fail, right? Because in this industry, the most common case for risks is actually pipeline failure. Like you might have some leaks or like it breaks down, which causes a lot of operational issues. And one other thing I want to point out is instead of scheduling visits, it actually makes sense to know from some metrics to see which area of your pipeline or which segment is most which one's most probable to fail soon, and actually schedule visits there. So it's more of a data-driven scheduling of maintenance operations. That's the basic idea behind this. What we have here is actually the data itself, which is in this CSV file that I've imported. There are a few columns in here which explain what the pipe size is, like what the thickness is, what material it's made of. You can see for the most part, the data here is numeric, right? So with numeric data, you can always munch this and use supervised learning or whatever to get some insights, right? That's exactly what we are going to check. All right, let me close that. Yeah, so we just try to visualize that data in here. You see about 10 to 11 columns. We have pipe size, we have thickness, material. There are a few objects. So that details like these might not be helpful, like what material it's made of, what grade. But if you look at the other ones, like what's the temperature of on that particular pipe, you could use this data to get some meaningful insights. That's what we'll be trying to do next as we look into the second step. So first step would be ingesting data, right? Getting the CSV file right. The second step could be like cleaning and processing the data to ensure it's fit for your machine learning purposes. Like null data is usually something that doesn't make sense, right, in your training setup. So what we're doing here is actually doing a check on whether some of your data might be null, then getting some insights on that. We currently don't have any missing columns, and you can also find the data types of this. The object data type is what might not be helpful to understand, like what's the material about. Like you can't make any numerical guess based on just whether it's made of steel or something like that. So this is where the exploratory data analysis becomes relevant, where just getting a quick histogram might point to some good insights. about some correlation, right? What metrics are correlated, and how you could use this to maybe predict the chance of a pipeline failing soon. Yeah.
This part is typical. This ED analysis is typically done by developers, data scientists, and so on.
Exactly.
This is not done through Kubeflow.
This is done.
Also,
So what I'm showing you is what you could do on top of Kubeflow. So this Jupyter Notebook, as you see, it's a Jupyter Notebook setup. This is running on top of Kubeflow. So
Can you show it from the Kubeflow UI?
Yeah,
How
yeah.
you got there?
So
Oh.
essentially the feature engineering, data cleansing, dedupes has been done prior to this process.
yeah, that's what I was thinking.
Yeah.
Usually that's a labor-intensive process.
Absolutely, yeah.
right, so you find this notebook. That's a good point. Thanks for. I think I jumped it. Yeah. I was too curious to show the demo. Yeah. So you basically have this notebook, which, as you can see, is running a Jupyter SciPy image, right? And if I click on connect to this, you will actually see this open up, and we can actually see the file that we'll be using. So, for instance, you have oil and gas pipelines, and this is the same file that I am showing on the other tab. Right? So, just to prove it's that, we'll load it. And as you see, we are getting the same pipeline. So I want to save some time to get the notebooks.
This interface is very similar to Colab.
Exactly, it's pretty similar to Colab, Google Colab, right? Okay, that was.
If you
Yeah.
are an Azure customer, your data should be in one lake fabric, and there's an agent and a process, AI processes that would go through the medallion layers. The gold, the raw, the gold, silver, bronze, silver, and gold. So that has been taken care of. It's not as intensive as it used to be, where human manually kind of label it, and then do feature engineering to to reduce the amount of computer process data that is meaningful instead of just white space data. But ultimately,
Right.
it's a bit nothing.
I think part of it is also having one platform for the different people to collaborate on. So if your data is in Azure and your data scientist wants to, clean the data before passing it on to the AI engineer, this is where Kubeflow is really special because you can do that on the platform. So you can, import your data. The data scientist can clean it in that same notebook. An AI engineer can go in, access those CPU, GPU, and create like one notebook where they're able to collaborate rather than working on like a laptop or a separate platform itself from your usual infrastructure.
So the collaboration platform.
Exactly. That's the end-to-end in there. In fact, I think I could answer most of your questions as I'm going through the demo if I do a theory of what each, one on the left is. Like, you have notebooks, Katib, pipelines, and all that. So what I'll do from now is, if your questions get answered as I go through the demo, I'll make note of that, and we'll go through the demo when I will cover that. All right. So in this case, I will switch over to the same setup. Right. So what I was referring to earlier is you have the ability on the left, if you notice, you have notebooks that you could create. So this is where the data analysts would go about creating their solution, like what they want to experiment with, right? The entire idea of this demo is to show how from a single notebook, right, you could use the different underlying aspects of your setup. So for instance, you need to do some training. You need to do automated machine learning, right? You could achieve all of this just from that single notebook. That's the end-to-end that you would get. Like, you start from, I'll show that as I go through this in a bit. I'll just go through this demo and then I will show you the whole pipeline, right? What we see here, this is more of a data exploration. If you see, there is some correlation. So we do some pair plots here. I think I may have to zoom. Okay, zoom is working just fine. Is it? Yeah, I just want to point some trends in the pair plot. So for instance, if you see the thickness, right, in here, you find the thickness is kind of correlated to your material loss. So let's look at the right corner here. You find the material loss find the thickness, and the pair plot here gives you a good indication, meaning when your thickness actually is less, the scope for having material loss is more, which, like, if you think about it, thick pipes tend to lose material lesser than thin pipes, right? So this is kind of what you could make out of this. You have other insights that you can get. Again, this is more of a EDA activity. So the next thing what we could look at is a correlation heat map, which gives you whatever we just saw in a numerical form. Like how good is one parameter or one feature correlated to another one in the setup, right? So you'll see in the main diagonal, you'll see 1, which means it's the same parameter on both axes. But if you see the thickness and the pipe size, right, they have pretty good correlation. If you think about it, the thickness needs to be more for larger pipes, right? So when the pipe size increases, the thickness should also increase. You could also notice, like I earlier mentioned, that the material loss percentage and the material loss percentage and the thickness, right, they are, in a way, they are correlated, right? So if for thin pipes, your material loss is higher. So you could use this to identify which features in your data are most important, what you could use to train a model, right? So that's the idea behind this whole thing. Let's push that.
What was the problem that you're trying to solve? Did the classification talk about what is the problem definition here?
The problem definition here is to actually create a predictor. Your goal is to identify how to use the data that you have to determine which category of pipes is going to fail. Yeah. Okay, so you're asking about the target variable. In this case, our target variable is the thickness loss. So use the other parameters that you got to identify how thickness loss might be influenced, right? What we see here, we actually run a quick random forest regression model here in order to check how it fares. The first 3 or 4 that you get on the condition is basically not quite helpful because this is an object. So ignoring that, if you look at the other ones like thickness, pipe size, corrosion impact percentage, temperature, time in years, you can see how this fares or how this influences the change in thickness. So you could use this in order to then make more insights, right? Again, this is more of a sample demo considering the time we have. If you want to jump too deep into this, there is actually one new notebook that I just found. It got updated like 6 days back. I can just show that quickly. If you go to the code on Kaggle, again, this is an open source platform. You can actually see that I think I can do a zoom here. That should just work. You can actually see that it just got updated 6 days ago. So you might want to explore that. That does really good deep insights into the data. The same data set, but making it to check maybe which machine learning model is relevant, how it makes sense and whatnot, right? I'll just quickly show you that. This is, I would probably rate it like a PhD level thesis design, checking which models you could use. It's quite large, so I just wanted to give that as a, if you want to learn more, check it out kind of thing, right? So yeah, we do have this, and I think with that done, I will go through the actual interactive demo, which will answer most of your questions to demystify this Kubeflow setup. This is, actually I wanted to do this demo first, but since we had some interest in oil and gas, we did that. We went with that first. So yeah, the ML model building pipeline here is basically the end goal, right? Is to use a wine data set, drinking wine, basically to understand the ingredients in that wine, maybe like sulfur, citric acid, things like that, to identify and determine how the quality of the wine is. Like, how would you rate it? Like, is it good? Needs more, work or something like that, right? What we do here, we get some, again, what you see here is all Python packages, right? Because you are working on the Jupyter Notebook. All this is Python packages that we're using. The packages we are using here is relevant because we do import the components of Kubeflow that we will be interacting with in this notebook. So you can find the name MLflow here, you can find kserve here, right? So these are components that we will be interacting with in the Kubeflow setup right from this notebook, as I will show you next. The pipeline actually has 4 different aspects, actually 5. You basically ingest the data, right? You have a CSV file, some data that you want to utilize in order to make sense of the metrics, right? You can then pre-process the data, right, to eliminate any outliers and things like that. Train your model with that data and then deploy or serve the model, right? So we will be seeing a quick example of how you would do that, and I'll show you a live demo on that, right? The first step is actually we are previewing the data set. You can actually see that we have a CSV file on some upstream source, right? It's the wine quality red.csv file, commonly used data set, right? We then visualize the data inside. So for instance, you can see the columns, right? It's like fixed acidity, volatile acidity, citric acid, free sulfur dioxide. These are the features of the wine in the entire data set, right? Now we will use this to make sense of the data. You can, after you download or prepare your data, you can ingest your data, which is basically, this is where the pipeline gets built. We write a function that just downloads the data. You provide a URL, it downloads the data, all right? The next step, when it downloads the data, it saves the data in some location, which will then be used in subsequent steps, right? So for instance, if you look at the process the data step, we have a function which takes the data set as an input, right? And then it gives you the processed data in the output, basically as an output file, right? You do some operation which is all like the data science and analytics folks, they excel at, right? So you could do this and, okay, that's it first. I hope I didn't get logged out. Okay, it is working, good. Yeah, so with this, after we process the data set, you can then train the machine learning model, which is you write another function that actually takes the processed data set as its input, right? And then gives you the model that you could then deploy, right? So this, you can actually see we are using the scikit-learn elastic net regression model, right? Again, all this is a demo. You are free to experiment with it. I'm just using it to demonstrate how the whole process works. Then you have you can then deploy the model, which is serve the model somewhere in the cluster, which can be used by an application. It's more like you using your Cloud Opus or Gemini, model or on that, something along those lines, right? Now, how we chain this all together is basically using Kubeflow pipelines. And to give you a reference of that, you can find the experiments KFP, which is Kubeflow pipelines, and the pipelines here. So, just a sec. Refresh. Right, there we go. So I have a few experiments that I've created, and this is actually going to create a new experiment when we run this whole process, right? And finally, there is an inference service. Again, this is something that you would use in order to deploy your model, so it can be used, right? I'll just create a new entry for this since I already deployed it earlier. So I'm just creating a new service called Wine Regressor 6, which will be the service, the inference service that gets deployed. And you are just going to deploy this whole pipeline, which should look like this. We actually download the data set, right? The data set gets stored somewhere. Then the same data set that we downloaded is processed, right? Pre-processed. That after that is done, you get the output, which is then fed into the model, and then you serve the data, right? Let's go ahead and run this notebook. It shouldn't take much time. I can actually explain it as it happens. Right? So we are done with it. I'm basically just repeating the whole process here on the Jupyter Notebook, which, when I create this pipeline, you will actually see, Now this is where we are actually passing the same URL, right, for the dataset, and then deploying the experiment. When it actually starts, you will see two links. One is the experiment details, and the other one is the run detail. So what's the difference between an experiment and a run, right? An experiment is actually a template that you define of how You get your data to how you serve your model. Run as an instance of that. So you could make an experiment, run it once, see if some changes are required, incorporate that in your experiment and do another run. Basically, this helps you quickly iterate through your experimentation, right? We can actually see the experiment details, which should open up. As you see, the status here is running, right? We have dynamically created a pipeline that is doing this process. You can actually see that the first step is done, which is it has downloaded the data set, right? If you look at the input parameters, we have passed a URL. You see, this is coming from our pipeline, the CSV file. After it is downloaded, it gets saved somewhere, and we use components within Kubeflow to do that. It's actually called Minio, which is more of a S3 compatible bucket storage service that is done on your AKA setup using Kubernetes concepts like persistent volumes, right? So everything is happening behind the scenes, but you are only looking at your workflow. Like you download the data, right? The data set you see here is, you can actually see there is a path. If I were to click this path, I can download the CSV file, right? Which got downloaded in the pipeline. The next step that we see here is the pre-processing that is happening, right? You can see the input artifact for this component in the pipeline is the data set. The output is your output file, which is the processed, whatever you did as part of your pre-processing, okay? And finally, that is actually stored in the output file, which you have a link to. Like if I click it, it will actually ask me to download the file, which I can use for, it's an intermediary, right? The main process here is to train your model. Here you can actually see that we give two inputs to, give a name to the model, and basically what name you want the run to have when the experiment is running, right? And you actually provide the data set that got pre-processed from the output, right, over there, over here. So if you want to look more into how this is happening, Kubeflow is behind the scenes orchestrating this whole process. Like it creates pods, and if you want to know how it's actually done, we use Argo CD, right, which is more of a CI/CD pipeline automation tool. It actually understands what the dependencies are, and it creates pods with injecting the data that you need in order to run, right? Yeah.
How about the when you prepare the data? Sometimes you have to, when you run the models, you have to do the folds between data. Is that orchestrated through this as well, or that's a manual process?
Yeah. It's not manual, but that's something that you could incorporate within you define the functions. Like what I'm showing is like downloading, pre-processing. You could combine that into a single pipeline. It depends on what the data analyst / the machine learning engineer, how they want to access the data. So it's up to you, but then you have the ability to chain them all together.
Just as a follow-up, that's fine. As a follow-up for the Kati, like the auto ML flow, does that have a folds like function? Like in the auto ML where you can just define it?
No, no, this is about, I think you're talking about, yeah.
Oh, okay.
This gets into the, you're asking about batches, right? Creating batches and epochs.
Oh, okay.
We will look at that. Everything what you're talking about is supported here. Yeah, it is supported, yeah. Quickly looking at the deployment here, you actually see that we don't find much here, but you can see the output. Let me actually show you, open it again and show you the logs, which should explain, maybe I can try and zoom it. Yeah, this time it works. Please bear with me. You can actually see that the model has been trained. See, it says registering your model. It already exists, so it's creating a new version of the model, right? And it actually registers the model on MLflow, which is where you track versions of your training, right? It also gives you the location where you can find details about this model that got trained, right? I will show you. Oh, this is too large. Yeah. MLflow can actually be opened from the Kubeflow setup. It's right over here, the last option in your segment. And we can actually see that, I'll zoom in. You can see that 1 minute ago, we actually created a new version of the model It's basically the same execution that I'm running, however, it's recording that as a new version, right? Now, if this model is actually like an LLM that you are actually training for your internal purposes, you can quickly go to the prompts, create a prompt, register it, and use your prompt to evaluate multiple versions of the model, right? In this case, we are doing a simple demo where we are not actually doing any prompts or something like that. It's a simple random forest check. So you have the ability to do that on MLflow, which comes after you have certified, okay, the engineer says this model works fine, you can try it out with your test set, right? That's where you can actually try things, you can schedule jobs to see if the model keeps performing well or some fine tuning might be necessary, right? You could do all that on MLflow, but I will jump to that later. Getting back to our demonstration, I think we opened it here, right? The final step here is actually to deploy the model with Kserve, right? Kserve is the component inside Kubeflow that will watch for your request to serve an inference, right? And this gets posted on a URL. I will show you this one. Maybe you can zoom in. Okay, I'm successful. You can see line number 48. After the entire process is done, this step actually says where your model can be accessed, right? And we will be using this in the next step to run a quick prediction, right? So after this is done, I think I will stick to this. Is this font viewable for everyone? I guess it's good. Okay, I think it's too large, but we can manage. Yeah, you can find. Yeah, I just showed you the MLflow side of things. Finally, after the model is done, we are just doing a quick check by giving two sets of inputs for all the parameters, like what the sulfur content should look like, everything else on the dataset. And you actually use the inference URL, which you find here, right? Which is exactly the same as what we saw in the logs, right? And we are doing you could write an app or a Flask app or whatever to make use of this data, but I'm just doing a simple post to that inference URL, right? Asking it to do a predict based on the data that I'm giving. Based on the data that I've passed, it gives two inputs or like two outputs, each giving or rating the quality of your wine between a scale of 0 and 10, right? So you can easily make use of this setup and downstream applications. So everything on that front can be done using Kubeflow. Right from your input data to training, testing, validating, deploying, fine-tuning if necessary, and then serving the model.
Where do you show the metrics, the scores, the performance scores?
Right, the performance scores. Right, you could run like R-square scores, for instance. You could write functions in order to do that, maybe with sklearn or something. We don't have that here. I have it on a separate demonstration. But you could do the same as long as you know your machine learning packages, the libraries, the scikit-learn packages that you could use in order to do that, right? Everything, it's more like your playground. Like the Jupyter Notebook is your playground. You bring in your functions and all that. What Kubeflow enables is it actually allows you to use the GPU or whatever that you need, which you normally might not have if you were to run on your laptop or an energy or performance constrained machine, right? So this is the idea behind centralizing every aspect of your setup into the Kubeflow environment, right? So I think I will stop at that. The final step is just cleanup. I don't want to do that. Let's go back to the normal font size. So you can actually see, in this case, we should find it under default. You can see the status has completed. If you click at this, it shows the same setup. You can find more details about that to see. All this is coming from Kubernetes. Like it schedules a pod that does this. It gets the output. That's a question. And then you can evaluate this at any point, even after the model is deployed.
Does this deploy the model as REST API?
Does this, in the end, is there a capability for this to deploy this as a REST APIs?
Yes. So that's the idea behind the Kserve component, which makes the model accessible as a service, like a Kubernetes service.
Yeah.
Now it's up to you if you want to use Azure Load Balancer to front that one and make it totally accessible to anyone that wants to use it. What we are doing here is accessing it internally within the cluster.
Gotcha.
just for the sake of demonstration. So it's everything that Kubernetes exposes that Kubeflow can also use. So yeah, the answer to your question is yes. Right. So with that done, I think we are on time here. I want to show you a quick GPU use case. So the other one to actually motivate you to use Kubeflow is the GPU CPU setup. So if you look at, this is another data set, again open source, normally available. It's called the CIFAR 10, which consists of 10 distinct classes. Like it gives, based on the image that you pass, right? It classifies the image and says, this is a truck, this is a cat, kind of a thing. So we are using that data set, but the goal here for me to demonstrate is how would your training look like when you run the demo on your machine, for instance, just using CPU, and versus when you run it on a really powerful machine with, let's say, the Tesla GPU, Tesla T4 GPU. That's the goal for this. Before I jump into, that's not a demo, I'll just show you the output. I'll want your attention on the image of the first two notebooks. So you can actually see, let me go back. I hope it's visible for everyone. Please let me know if it's not. You have two notebooks, right, which start with CIFAR 10. The first one is a CPU notebook. And notice the number of GPUs you find on this segment, right? Like you see, there are 0 GPUs on the first notebook. Pretty much everything else is the same. You have 2 cores, you have 4 GB of RAM, right, for this notebook. And the other one is actually using TensorFlow with CUDA. The image alone changes. If you look at this, the main difference is the image changes, meaning what I'm talking about the image here is how is your notebook actually running? Because you put the image into that container, into a pod, which is your notebook. So you're using a different container that has support for TensorFlow libraries, like CUDA and all that. And you can actually see we have a GPU in here. That is exactly what we are seeing here. This is my CPU notebook, and the other one is my GPU notebook. I'll show you quickly how the training is important. I think this is relevant to your question. So, one moment. Let's get to the part where we actually, this is by the way using a CNN, a convolutional neural network with multiple layers and all that, using OpenCV and all that. But if we get to the training part, right, training the CNN model, this is where you create batches, you create epochs to do the training, right? The goal is to reduce your loss, increase your accuracy, right? Excuse me. Yeah. So you can actually see I run this operation for 100 epochs with, let's look at the batch size. It's a batch size of 64. I think this is what you were referring to earlier, sir. Yeah. So when we look at this, one thing actually stands out, which is the time it took for one epoch to complete. You have 64 images in the batch, right? And you are running it for 100 epochs. One epoch, right, with 2 CPUs and 4 GB of RAM, actually took me 194 seconds, which seems to get somewhat standardized, maybe like 188. The lowest seems like 187. Let's keep it 180, okay? So it takes roughly 3 minutes for this whole process to run. So you can actually see that I ran this whole epoch for close to 6 hours in order to get the training done. And you can actually see, visualizing the learning curves shows how your loss has reduced all the way to roughly 0.5, right? From a large amount. And the accuracy is also, you can validate it with the training set and the validation set. Now let's compare the same with our GPU based node. Okay, let's can't access it that way. Let's get to the same location. This is actually using GPUs. And I want to show you how the GPU is basically recognized. The easiest way to do that is to run an NVIDIA SMI command. One sec. But I guess I haven't stored the output, which is alright. Let me do a live demo to show you. Let's open a terminal, and in the terminal I'm going to run the NVIDIA SMI, which actually shows you the tensor, the GPU, right, which is a Tesla T4 as you see here. The RAM here is like 16 GB, right? That's the GPU that we've taken from AKS, right? The worker node on AKS, which we will be using, or which I've used for the training, right? So if you run this command on the first notebook that I showed, meaning this one, this command just wouldn't work because this doesn't contain either the CUDA libraries for NVIDIA's GPUs, nor the actual physical GPU in the worker, right? So when you look at the time it took for this whole training process of, let's say, one epoch, you can actually see that it takes roughly 47 seconds, and at times it actually converges to even smaller number, like 25 seconds. In this case, we have actually offloaded the whole training, right? Because it's all parallel computing. We've offloaded it to the GPU, and you can see how quicker it completes. Now, this is something that you can again do on a same platform using the same setup with different images if you want. I think I was talking to Yash about this. If you have, let's say you want to do machine learning with confidential data, right, which is not supposed to be shared outside, for instance, and you also want the notebook to be super, how can I say, hardened, right? Like FIPS, for instance, you have PCI DSS requirements that you want to do. You can bring in custom notebook images, right? You could do, for instance, you want to do the sys hardening, right? Or you want to basically ensure your pods have least privilege and they are authorized to run workloads that have very high level of sensitivity, like confidentiality, right? You could do that on the same setup. It's just a matter of updating your Kubeflow by adding this image, and you can just go back to the same setup here, create a new notebook, and when you go create a new notebook, you have the ability to choose your image. So in this case, we are just looking at Jupyter Lab. If you want a hardened image, we can make that available here. So for dedicated use cases when you want to run them, right? So in this way, I think this is the first time I'm sharing this here. So this is where you can choose which IDE you want to use to create the notebook, right? So you have Jupyter Lab, you can create a VS Code setup. Again, this, if you want, you can also use GPUs in this configuration, right? And for the pure data, scientists and analysts who want to do like RStudio based one, like it's a R language, you can use the same setup for IDE for your work. So this concludes actually the second demo. The goal was actually to show that you have a really, and you can actually see here that your validation loss doesn't get reduced. So we are almost saturating the whole training. Right?
Sorry, I didn't know it. So, I mean, you have shown a lot of code over there, which is like all this TensorFlow code, I guess. You probably may have some libraries that you use internally to connect to your system, I guess, right?
So everything.
Yeah. And then how do you actually integrate this with Azure DevOps? Is there a GitHub that you use actually to check out code from Azure and all those?
Yep, that's a good question. So Jupyter Notebooks come with the default ability to clone repos, and you could also link other platforms that you'd want for DevOps pipeline. So in fact, I've done something similar here. You have a function here that can actually quickly clone. You can actually see there is a clone a repo function that you could use to bring rather than manually uploading notebooks or creating from scratch. It's easier to clone a repo from, let's say, that's a yeah.
I see.
So yeah, that's also available indeed. Yeah. Cool. So again, whatever I have done there is actually available on Kaggle. You can just search the CIFAR 10 image classification, and you'll get the notebook. The only difference we are doing is we are using two separate types of images with two different access to hardware to demonstrate it. Right? So that's the second demo. The final one I have is quite interesting. This is again Kubeflow pipelines. Like I shared earlier, like you can create data set, you can pre-process the data set, train it. But in this case, I want to focus on something unique here, which is automated machine learning. So that's actually called KATIB inside Kubernetes. I'll try to give a quick theory of this. Basically, you have some data set, right? but you don't know what the right parameters for it would look like. And what I'm talking about parameters here is something like your learning rate, could be the batch size, could be the classification algorithm you're using, like the search optimization that you're doing. For instance, do you want to do, let's say, Bayesian optimization, or you'd want to go with something random, right? Now, for someone who is not a real pro in all these things, like having a PhD in math and everything, right? You would actually find it easier if there is more like a dialogue based workflow that gives you these options, and as long as you understand what it does, it's like an applied thing rather than going through, what's the exact function required to implement it. All you have to do is just figure what or what search configurations is better for you. So I'll do a quick demonstration of that. When I click on new experiment on Catib, right? The first ones are a bit. Let me zoom in a bit. I think this is doable. Yeah, I hope it's visible for everyone. So you can give some name. Basically, this is going to be your experiment name when you run it. You can choose the trials. So in this case, what is actually happening is until an objective is reached, the objective could be my loss should be less than 0.5% or something. My accuracy should be 99%. Right? These are objectives. Until an objective is reached, I think you will find the objective here. Maybe we should do this first. See, maximize my validation accuracy or minimize my training loss, right? So you could select this, right, and then give give a threshold, meaning Catib will automatically launch multiple experiments, right, and with different hyperparameters, or in this case just parameters that you are using to train your model, right, and it will automatically identify what's the best performing trial, right. Now it's up to you, like if you go down, like this is the idea, like how many parallel trials you want to run, give it a maximum count, so in case you are not able to, optimize it further, give it a stop condition, right? And then if you look at the search algorithm, this is very interesting. So this is where the hyperparameter tuning that I talked about becomes relevant. So you have multiple options here. For instance, random is basically, you have your optimization search space, right? There are different configurations that you will get. Random is just going to randomly select from the available space, meaning setting the batch size to 50, for instance, when you can set it between 30 and 100, right? So it's going to set batch size to 50, then maybe the learning rate to some X value. The next experiment, it will randomly select another combination, right? So this is random. You could do Bayesian optimization, which means it learns from the previous inputs to the hyperparameters that you pass, right? In order to wisely choose the next set of hyperparameters, so that results in lesser iterations and faster accuracy, like getting, how do I say, like it gets to your local minimum faster than what you would do in a random setup. Again, you have other options here. These are just like a drop-down setting that you can do and configure it, rather than writing the exact functions and identifying how to inject your data into that. So Catib actually makes it easier for you to do like a quick start of your machine learning. You don't know which model to use. You don't know which features are relevant, right? You could run a quick Catib experiment and then use the output to identify, okay, it seems like if I set my learning rate to this value and then maybe the other parameters to some other setting, then there's a good chance my training will happen fine and the model accuracy improves. So
can you also combine them as a set of experts approach where you run multiple models?
Yep. Again, that depends on what is available on the Kubernetes setup. So all these have been implemented in the Kubeflow setup, which is why we are able to see them and access them. You could also customize your functions, like a mixture of experts, I think, something like that. It depends on your use case and what is available. So it can be done, yeah. And you have other settings like the early stopping, if you would want to configure that. This is what I was referring about. You see, we have 3 settings with some configurations for your learning rate, the number of layers, right, and which optimizer you want to do, right, like Adam optimizer and all that. You can see that we have 576 different combinations, right. What Catib would do is, based on your search algorithm, right, whether you want to do random or grid search, right. Grid search basically is like where is grid? Yeah, you have it will basically run every combination. It's like you're brute forcing your password, right? Something like that. So you could do that, and I just want to do a quick demonstration. If you see 576 here, see what happens when I remove a parameter. It's reduced. So it's basically giving your, what all values can you set, like fine tuning multiple small knobs. Cat will automatically do that for you. How it does is like behind the scenes, it creates multiple pods, it has a controller that monitors and things. But yeah, from the use case of your machine learning experiment, you can use Catib. I think I can show you a demonstration of this. Let's quickly jump into it. In fact, this is the output of the demo that I wanted to do live, but it doesn't matter. I can actually show you how this works. So let's go ahead, and in fact, I would want to quickly kick this off. This is the Kubeflow pipelines demo, which uses a different dataset. It's called MNest. MNest has grayscale pictures of handwritten numbers, right? And the outcome of this is you use it to assess how good. If you give you manually write 9, take a photo of that and give it, it should be able to guess that is 9. Right? It's more of a image processing use case, right? Let's quickly go to this and run the experiment. Let's see if it works. You see, I've kicked off a new run. You see, the experiment details stays the same, right? Which is, you can let me zoom in a bit. You can see the difference in color, right? Like the link, it seems like I've opened it because the experiment is the same, but the run is different because I'm running a new instance of the same experiment. So this is how you make a change, and you can see how the changes that you make reflect in the outcome of the pipeline. Right? So let me open up the run, which should just show you the same setup. In this case, we are launching, again, this is a pipeline, so we are doing multiple configurations here. The Catib launch experiment, if I open the Catib setting here, you can see there is a currently running case. Let me refresh the screen. We should see this running. Let's get in, right? And you see it's actually creating a trial which was created 1 minute ago. The experiment is created, and if you go to the trial, it's actually going to run some pods, right? This is the name of the actual pod where it has automatically randomly selected the parameters. Say the batch size is 98, for the next run it is 94, because I've set the parallel runs as 2 and the maximum runs as 5. I can take you through the code, but you can trust me on that. Yeah, and we are choosing a different learning rate. So we are just changing these two settings. We are letting the trial run, right? When the trial succeeds, right, you will get like a graph that explains this whole thing, which is what I'll be able to show you on a completed run, right? You see, there are 5 different runs, and you can see the learning rate that was configured for each run, the batch size that was chosen for each run, and this is more like an output, like what was the loss for those configurations that we chose, right? And Catib will automatically identify the best trial in this whole setup. So if you go check where is the trial tab, you can actually see that there is one that is highlighted in yellow because that has the least loss. You can compare it. Like the first one has like 50% loss, the second one is like 31% loss, but the third one has the least, which is 20%. I don't know how to actually convert it, but you get the idea, right? Like the loss here is least. Now this is a way for you to build really powerful pipelines, like that can do iterative training, that can cut short something that would actually take ages. If you know how to actually do that, you know it, but you want to experiment it, Kubeflow gives you the ability to do that with Catib. Right? So let's go ahead and see what's happening in the existing one. I hope, yes, that's good. We are seeing 2 experiments have completed, and it's actually creating 2 more, and we'll do that until 5 experiments complete. Right? So you can actually see the experiment is running. If I go to the trials, actually you see how it's tracking the run or the trial with the lowest loss. Right now it is 0.35, right? If the next 2, the ones that are currently running, complete, then it's going to choose that particular one if it's lower than 0.35, right? And this actually maps to what we will see here on the Catib experiment. You can actually see that Kubeflow is creating all these pods. See, current condition for experiment, it is created, it is running. So Kubeflow, behind the scenes, there are controllers that monitor this. You don't have to worry about any of that. All we have to do is choose. You can trigger this from the Jupyter Notebook. You just write Python code, and Kubeflow automatically identifies how to go about implementing it, like creating the pipeline and executing it. The pipeline here actually is more of a, I can show you the title here, which is, we run the catib first, we run 2 TensorFlow jobs to identify or to perform distributive training, basically splitting your training into multiple small jobs and running them parallelly, right? With the parameters that, the best parameters that we found from the catib experiment. So, yeah, is there a question?
Where is your version control of all the configuration? In other words, for hundreds of runs, you need to now go back and say, you know what, we were better off 2 days ago, right?
Right.
You want to pick up that and start from there.
Got it. So we are currently not registering the model here. This is, each demo is focused on one specific thing. But for your use case, you would register the model that you are creating as part of this thing in MLflow, which will then start tracking. They give it a version, and then you will have the exact data set that you were using and the parameters that you chose, if you would want to repeat that experiment from MLflow. Right. I'll quickly check what's happening. Oh, there we go. So we actually saw initially it was at 0.35, right? Now it changed to 0.20 because we are using the random one. If you use Bayesian optimization, I guess the parallelism will be slow, but the next configurations that Kubeflow or the catib uses would be more informed. Like it knows how to tweak the parameters in order to better get results. Like rather than randomly giving you some settings, and you could actually see a few settings are like a few trials have losses that are greater than what it was in the first couple iterations, right? So you could change the search algorithms and all that on Kubeflow. Again, this is an easy way for you to try things out before actually determining what's the best way forward, right? So this, actually this is the point, and you can actually see right now that we created the experiment, we get the catib results. Again, how we are defining this, you need to look into the Jupyter Notebook code, right? I went through the code. If you are interested, I can walk you through that. But essentially the point is you get the learning rate and the batch size of your best trial and use it to then run the Kubeflow job. Oh wait, I think if you want a picture, you can go ahead and take it. Yeah. So you have the best trial name, right? It identified the trial with the observation which has some metrics, and the parameters has the learning rate with a value, then the batch size with a value. Now this is what is fed into your Kubeflow tensor, like TF job spec, where it creates a couple of pods like chief and workers and all that in order to do the distributive training. Right? Once this is done, you get the output, and if you want, you could serve it or do any downstream processing that you want to do. Yeah.
You mentioned that the data science team can modify the parameters on the interface, right? But you can also use grid search algorithms that you can provide the input set of parameters, minimum and maximum, and then the grid search will run all of them. So I didn't see an example. I'm sure it's probably supported. It's a very standard thing.
It is indeed supported. For the sake of this experiment, we went ahead with the random configuration. So let me show that in code to prove that I'm not doing any magic. Just a moment. You will actually see the configuration here where we choose the algorithm's name as random. Now, don't get bogged down looking at this code. Thanks to LLMs and Gemini and all that, you can easily generate these things rather than going and figuring out which function I need to use in a library and all that. Right? So in a way, it's AML helping you do AML better. So yeah, with that, you have the same configuration. If you see, you create the trial specification. I want you to map this to our Kubeflow UI, right, where I showed you the trial settings. Then you have the objective specification, right, whether you want to minimize. Let me show that. Basically, if you go ahead and create new experiment, you can actually see the same trial thresholds, you can see the objectives, you can see the search algorithm, right? So, yeah, we do basically the same setting via Jupyter Notebook. The idea here being you can actually use this for dynamically creating or consuming all the components within Kubeflow and then making the end-to-end pipeline in a more transparent way. Okay? So I think that those are the 4 demos. I think I did that in time. Maybe if you want, I want to share one thing that might be helpful. So Kubeflow actually helps you do collaboration, right? So you might be the owner of a notebook. You can actually see that I am the owner of this workspace called Managed Kubeflow. Now I can actually add other users, right, into the namespace. So they can also come in and experiment with things or help do collaborative troubleshooting and all that because it's synced, right? So this is more of a for those who manage Kubeflow for administrative tasks and all that. So yeah, that is another thing. There are other more features. We have basically just scratched the surface. I'd probably have to deliver a day-long workshop to dive into the other features, but I hope this gave you some inspiration. Are there any specific questions?
Does it suggest a better combination of the infrastructure to save cost?
Sorry, missed your question.
Yeah, I'm saying, does it also, because it has a good visibility on the execution process, can it also suggest cost efficiency in terms of what combination to use?
That's a good point, which reminded me that I have to show you guys about the cost part, which is the observability part. So I have it ready. This is usually, okay, to fill you in. The answer to your question is we are deploying this on Azure, like AKS settings around that. So the cost would actually be what Azure charges you. I would back off to Brandon or Yash to discuss the pricing on the managed part. But I believe the cost optimization or like the visibility into that is quite clear from your billing account on Azure. So if you have a corporate account, for instance, you have the same ability.
That cost is not passed through into the Kubeflow pricing separate.
Yeah, Kubeflow is an application, right? So it is using building blocks from your Azure setup, like load balancers, auto scaling, VMs, external names, public IPs, PVCs, or like block storage. Like it's using all these components in order to create the environment that people struggle if they were to follow the upstream process. Right? So that's the idea.
So other than the Azure infrastructure, what does Kubeflow cost? Is that your question? Where's my question? That's my question.
Your question's right. The answer should come from.
The cost is a percent.
The cost is a percent of the infrastructure, so we charge based on the usage charge, and that's billed directly to Azure, so that goes to us. I think Brandon can specify like the exact cost based on your setup afterwards.
I mean, it's a low single-digit percentage, right? Is the general gist.
That's normally for Ubuntu VMs, so I think for Kubeflow it's percent. Yeah.
Okay.
We can specify the exact amount. Yeah.
Good math. Thank you.
But that sounds intriguing. Why is it pegged to Azure's infrastructure cost? Why not a straight license cost per user per seat? Why is the model tied to infrastructure cost? Because if your model is huge, your data set are huge, then your infrastructure costs run into huge. Correspondingly, the usage of the application. That's unusual to peg
The
something
level of
in
support.
underlying infrastructure cost.
For marketplace offers, it's not that unusual. Because
Pay per use. It's normal.
it's very normal for marketplace
The more you
offers.
use, the more you pay.
No, but you're talking about Ubuntu application, right? It's sitting on top of the infrastructure. The use of the application has its features.
So the application itself, if you want to download Kubeflow inside yourself on Azure, you don't have to pay Canonical all the time. Like everything we do is open source. The cost that you're paying when you're doing the managed Kubeflow on Azure is all of the operations and the maintenance of the application is done by engineers from the managed solutions team at Canonical. So you don't have, it's essentially the same as AKS. You're not managing the Kubernetes underneath. It just runs for you. So that's the part of the cost that goes to Canonical, is to support the infrastructure. But you can download the Kubeflow code from our website, install it yourself. You're just gonna have to manage it all yourself too. Yeah.
So I just wanted to quickly show you how the managed solution team that Cami just mentioned, like those folks have a visibility onto the infra side of your setup. They can't access your workspace, right, or do anything on top. But you can actually raise support tickets if you face issues with some feature, like you want to use a feature that's not available that you want integrated, right? You just raise a support ticket with Canonical if you want to saying what you would want to do, right? Like maybe a custom image for your Jupyter Notebook, right? So this is where that email becomes relevant. You would need to contact on that, and then like Cami mentioned, we would then be able to assess whether that feature is implementable, ensure we have support mechanisms to provide long-term support, and then incorporate that as well. So what you're seeing here is more like a multiple different dashboards, right? Again, don't be bogged down if you don't understand much of these. This is all behind the scenes. I just want to show you the different components that are running to help ensure everything that you do when you create a notebook, when you try to run a pipeline, right? When you try to serve a model, when you're trying to automatically, like dynamically scale your inference services, when you're, this is a good use case. Like most of the users, when we run a command, we actually want the AI to, like ML, to give us a quick update, right? You don't want it to keep thinking longer. Actually that translates to the time it takes for your model to do the inference. That's where scaling becomes super critical, right? Scaling as in like you have certain, it's all REST API, right? You're sending some tokens, you're getting some results, right? You need to ensure that there are enough workers available for doing that inference. So that's something that behind the scenes you'll see this. For instance, the Minio, right? That's the AWS S3 style compatible connector that uses PVCs from your Azure setup, like your block storage, where your notebook's local data content gets stored. Right? You can actually see how long this has been running, how many buckets have been created, how many objects are in there, and all this is about, just a moment, we're getting like an overall request. You can see how the requests work, like for every node, what is the IO, right? What if there are any errors in your S3, meaning is Azure actually getting overloaded with your requests, like when multiple engineers work parallelly, right? When they want to execute things and they want to parallelly work, right? So ensuring if there are any IO errors, right? Our team would monitor this to ensure you never feel the pain, or any issue that you will see will be predictively, solved by the team. So that's the idea and the value add that Canonical brings in. It's all open source. We give you production level support so that you can focus on things that you do really well without having to worry about patching CVs, upgrades, kernel upgrades. That's all on Canonical. We take care of it. You ensure your ML story is working end to end fine. So that's that's the idea. You can actually see, I think this is showing it for a particular setup. You can actually choose. This is all behind the scenes. I would actually want to show you quickly that one as well. So if we get into the terminal, you can run quick show of hands. How many of you folks use kubectl, Kubernetes? All right. So the idea is to, so whatever we did so far, right? It's actually using pods in here. I will do, maybe let me do a quick, how do we zoom? Yeah, I hope this is readable to some extent. You see the download, pre-process, train, deploy, pipeline, like what we did initially, like building your pipeline, where we downloaded CSV for the wine training. All my notebooks here, I think I'll go back to the same setup, that's easy. You'll see it either completed or there's an error or something. All these are pods, that or jobs that got completed, and you have the remnants here, like the MNIST training, the CATIB experiments we were running, right? Those created their own pods. And if you look even down below, the CIFAR notebooks, the two notebooks, the GP notebook and the CP notebook we were using, they have their own pods, and you can see the status is running. This is actually showing you a notebook that's running, and in fact we are seeing it from here. So you can also see the same setup, ML pipeline tutorial 0, that's running, and that's actually this notebook. We are able to access it. It's like you can manage and view things within your namespace if you are a Kubernetes administrator. So this is for the CKA, CKAD folks. Basically, these are things that we will take care of, so you don't have to worry about. You will just raise issues if there are any, right? So, yeah, that actually completes the demo. There are a few more things I could talk about, but if there are questions, yeah.
Yeah, questions? Anyone online? If you want to come off mute on the folks online, that would be not a problem. All right, I think we've got them as we went, Vikas. Excellent. Well, who learned something tonight? I did. Yeah. I think when I Linux, I'm gonna Canonical myself. I shall Ubuntu it from now going forward. Thank you, Vikas. Really appreciate it. This was really good. Thank you for Canonical folks for supporting us tonight, coming out and educating us, frankly, teaching us. We really appreciate it. And we don't have a speaker planned for next month, but we're working on it.
Oh,
so.
that is a raised hand from my lady.
Oh yeah, go ahead. We got time for questions. Quickly.
Hi, sorry, I actually don't have a question. I really learned a lot from Vikas. Thank you for that great presentation. It was really a lot to take in, but I took a lot of notes, so thank you. I wanted to ask the organizer a question.
Oh, me? Sure.
Because I tried to message you, but I don't think you have any text.
Yeah, there might be something wrong with that Teams. You're trying to put messaging in the Teams. Yeah, there was something wrong with that. Sure. You can use the Meetup app if you want to message me.
Oh, okay. Yeah, it was just for like a networking event they had coming up at Microsoft as well, and I just wanted to share that with everybody else. They were interested. It's in April.
Oh, all right. What is this event? You can tell us.
It's also for SQL and AI Linux. It's part of the User Group.
Oh yeah. Is that this weekend?
It's in 2 weeks.
2 weeks. At the weekend on a Saturday?
Yes, on a Saturday, and it's like a full day and
Yes.
a lot of speakers.
Yeah, there's like 100 people registered for that. So anyone else in Houston wants to learn about some SQL and AI, this room in 2 weeks on a Saturday. Yeah, see, it's a meetup event. Yeah. Not us. That's not our group, but I know about it. And thank you. What is the name? It's SQL and AI meetup. Oh, who is that?